Hello, welcome to this mini lecture on polymorphism and interfaces, as well as a walkthrough of questions 1 and 2 on the worksheet. So, what do we mean by polymorphism, right? It's this big fancy word, but what is it? What does it mean? What are we talking about when we refer to it? So let's think about medical doctors for a minute, okay? There's a lot of different types of medical doctors, right? And they might all perform different procedures, prescribe different medications, diagnose different conditions, right? But at the end of the day, there's a certain set of things that we expect all doctors to be able to do, regardless of their specialty. Okay. Washing their hands would be one of them, performing some sort of intake exam, and having an understanding of biological systems. Okay. Now, it doesn't matter how the doctors do these things, right? The specifics are not what we're concerned about here. For example, a neurologist might perform a different type of intake exam than a pediatrician. They might ask different questions or, perform different tests or things like that. We're just concerned with whether or not the doctors, can do these things in some way. Okay. So let's think about an example here for a minute. Let's say that I need to go to the cardiologist for an intake exam. But when I arrive at the cardiologist's office, I can't remember the word cardiology. Okay, for whatever reason, it slips from my mind, and I can't. I'm unable to specify the specialization of the doctor. Right, I can't verbalize the type of the doctor. So I can't say I'm here for a cardiology intake exam. But what I can say is something more general. I can say I'm here for an intake exam. Now, what's going to happen in this situation? Am I like out of luck? Like, is the doctor going to like become confused and like not know what I'm talking about when I just say intake exam? No, of course not, right? The doctor knows their own specialty, right? The doctor knows that they are a cardiologist and that they should perform a cardiology intake exam. They don't need me to tell them to do that. They know to do that on their own, right? So, what have we discovered here? Okay, we've discovered a universal method for invoking type specific behavior. I can go to any doctor, right, and just say, I'm here for an intake exam. And I can expect that they will perform a type specific intake exam. Now, why is this even important and why does this matter when we're coding? Well, let's take a look at these two different types of code that I could write. So on the left, I have to specify a method for performing an intake exam for every type of doctor, right? And these are just, three types of doctors here: cardiologist, neurologist, pediatrician. I mean, there's so many other different types of doctors as well. And I would have to write a method for each of them. And that's very verbose, right? And also that makes editing my code really, really difficult, right? Let's say that within my intake exam function for here on the left in the verbose version, let's say I want everybody to like do something such as call in an assistant. Okay, then I would have to go into every single one of these methods and like add that in to all of them, right? Now, let's look at the right side. The right side is a lot less verbose, right? I am just doing an intake, one method for an intake exam, and it's going to work for any type of doctor. Okay. Now, if I have to add something to all of these, doctors' intake exams, I only have to add it in one place, right? If I need to do some sort of call to, an assistant, I only have to specify that in this one less verbose method. Okay. So what we're seeing here is polymorphism. Polymorphism is when one object can take on different types. Okay, so in the right side, we see that the public void intake doctor doc, that doctor right there can take on many different types. Okay, that's a single object taking on many different types. That is polymorphism. So, okay, now we understand what it is, but how are we going to make it happen? Well, in Java, we have something called an interface. And an interface is a blueprint with method signatures that define what an object can do. Okay. So over here on the right, I have my public interface doctor, and it is defining the things that we discussed earlier that all doctors should be able to do, right? Do an intake, give some sort of expert opinion, wash hands. Now, those things, the interface, will be implemented by a subclass that's going to define how those things will be done. Okay. So I have my neurologist, class neurologist implements doctor. This is a subclass of doctor that is going to uh, define how a neurologist should perform an intake exam or give an expert opinion or whatever. This is done by overriding all the methods in the interface. So remember, we override methods by using the exact same method signature. Now, here's just a note that I think is important. Okay, so well, a class can implement multiple interfaces, but can only extend one class. Okay, now how do you remember which one? Do you implement interfaces, extend classes? Just remember that the I goes with the I. Okay, so we implement interfaces and then we extend classes. Okay, now we can do the worksheet problems. Okay, let's go over part 1.1 of StarCraft 2, okay? So consider the following interface and implementing class. Okay, so we have a worker interface, and it looks like workers are doing things like having a favorite resource and a favorite phrase, okay? So remember, our interface is a list of things that workers should be able to do, but not a specification of how they're able to do them. However, we do have the option to provide a default implementation for methods and interfaces, okay? So we're seeing that right here, default void work. We are specifying how a worker should work. But here's the thing about defaults. They can, of course, be overridden. Is that even how you say it? I don't know. But you can override the default methods within an interface. They're more so just things to fall back on in case we end up having a subclass that doesn't provide specific implementation of something. Okay, so do we need a work method in SCV in order to make an SCV work? So the answer to this is going to be no, okay? The reason why is because we have that default keyword. So even though the work method is not defined in our subclass SCV, we can look it up in the parent class, which is worker, and use it that worker.work method. Okay, so that is part A. Okay, how about part B? What does the following two lines print? Excuse me. Worker SCV will be equal to new SCV, SCV.work. Okay, so what's going on here? Well, remember, we talked about static and dynamic types last week, right? So I like to put the static type in here and the dynamic type in here. Okay, so what's going to happen at compile time is we will look in the static types class for a method with method signature work, and we will find worker.work. And then at runtime, we will check and see if we can upgrade. So we're going to look into the dynamic classes body and see if we can find a method with method signature work. We don't see one, so we're not going to upgrade, and we are just going to use the worker.work method. Okay, so I'm going to say gathering. Now, favorite resource, that is defined here in SCV. And then favorite phrase is also defined. So I'm going to say gathering minerals, woohoo, overtime. Okay, now let's look at part C. So let's suppose we define a new class that inherits from worker and attempt to run a few lines of code. So we are overriding our favorite resource. We are going to have our favorite resource be Vespine gas. Now we say worker probe will be equal to a new probe, and we call probe.work. So do these lines error? Is it a compile time or a runtime error? Okay, so here's the thing about interfaces. We have to override all of the methods in the within the interface, okay? We have to, we have to implement them in some way, right? If we're claiming that probe implements worker, then it better actually do that. And Java is going to make sure that we are actually doing that. If we are not providing some sort of way to, tell people what our favorite resource is, to say our favorite phrase, if we're not actually implementing those methods, then that's a problem, right? This is not actually happening because we don't have an override for favorite phrase, right? We're missing one. So when I do this down here, I'm going to get a compile time error because I am not overriding favorite phrase. So that's why the answer is compile time error. Okay, now let's do question 2, Pokemon. Identify the errors that occur when compiling and running the code to the right. I actually put it, oh well, it's actually below. It's this code is what we're going to run. This is the code that was provided to you. Assume that if a line errors, it will not affect the execution of later code. Okay? So we are starting off by saying, okay, so I'm going to kind of just keep track of the static and dynamic types of P and A, okay? So this will be P, and this will be A. This will be the static type, and this will be the dynamic type. Okay, so what is the static type of P? Well, the static type of P, whoops, that's not readable, is going to be Pikachu. And what is the dynamic type of P? Well, it is also Pikachu. Now, how about A? Static type of A is Pokemon. Remember, the static type is the thing to the left of the equal sign, and the dynamic type is the thing to the right of the equal sign. So the dynamic type of P is going to be Pikachu. Sorry, of A. Okay? So now let's look at this line right here. P will be equal to A. So what I'm trying to do here is I'm trying to assign something with static type Pikachu to something with static type Pokemon. Okay, now remember from last week, we talked about the relationship between the static and dynamic type. The dynamic type needs to have an is a relationship with the static type. Oh no, am I recording this? I hope so. So now we can ask ourselves, is a Pokemon is a Pikachu? Well, this is similar to our dog poodle example, right? Or dog beagle example, right? Some dogs are poodles, some Pokemons are Pikachus, but not all of them are, right? So this is just not something that we can say for sure, and this is going to be an issue, and we are going to get a compile time error. We could solve this by doing a cast. We could cast the Pokemon to be a Pikachu, and then we wouldn't have a compiler error, a compile time error. Now, what happens when we do a dot eat? Well, A has a static type of Pokemon, so I'm going to look in the Pokemon class, and I'm going to jot down a method with magnet method signature eat. Now, runtime is going to come around, and I'm going to look into the subclass of the dynamic type of A, which is Pikachu, and I'm going to look for a method with method signature eat. And I find one. It's going to be right here. So I am just going to print nom Pika nom. It's kind of cute. Okay, so there were no issues with that. Now I'm going to say A is equal to new Squirtle. So I'm changing the dynamic type. So now I am interested in calling A dot attack. So A has a static type of Pokemon, so I'm going to look in the Pokemon class for a method with method signature attack, and lo and behold, I do not find one. Okay, be very, very careful when looking at these method signatures. They have to match exactly. They have to be exactly the same. And we can see that in the Pokemon class, the attack method is taking in a Pokemon, but that's not what we have down here, right? We have something that doesn't take in anything. Now that is something that we find in the Squirtle subclass, but at compile time, we are not concerned about dynamic types, right? We're thinking about static types. So this is going to end up being a compile time error because we can't find a method with that method signature in the static type class, okay? So now we are going to cast A into being a Squirtle, right? So this is a cast right here. And we're casting A into a Squirtle and then calling A.attack. So at runtime, what's going to change about this? Well, at runtime, we're kind of going to temporarily, at compile time, what's going to change about this? At compile time, we're kind of just going to temporarily set aside this static type of Pokemon, and we are going to do our checks as if A had a static type of Squirtle. So that means that we're going to look in the Squirtle class for a method with method signature attack, and we will find one this time. And then when runtime comes around, we're once again going to look into the dynamic type subclass, which is again Squirtle, and we'll find this same exact attack method, and we will be able to say water gun. So that worked out, okay? Thanks to the casting that was performed here. Now we're going to say Pokemon Z is equal to a new Pikachu. I'm going to get rid of this. Okay. And now we're going to say Squirtle S is equal to Squirtle Z. Okay. Is equal to something that's Z being cast to a Squirtle. Okay. So what's going to happen here is when we do a cast, we're basically telling Java that during compile time, Java just needs to trust us, okay, in terms of the type checking. We don't actually want to look, we don't want Java to actually look into the details of Z during compile time, okay? We are telling it, Java, that it just needs to trust us that Z is going to end up being a Squirtle, okay? So for purposes of compile time, there's no issues with the relationships between the static type and dynamic type of S, right? They're exactly the same. There's no violations or anything like that. So compile time will be fine. But during runtime, we are going to get a runtime error because something with a dynamic type of Pikachu cannot be cast to a Squirtle. Okay, so this is going to give us a runtime error. So down the road, you can kind of think of it like in that sense. The cast, it solved our problem right now, but down the road, we're going to run into issues because this is not a legal cast. Okay. And I think that is all of the worksheet problems. Okay, so thank you for watching.